Hi, class. This is Mr. Scheidegger. It is Thursday morning. I'm not going to be in class today, and so I'm hoping to be able to show you what you need to know in this video. So, what we're going to cover today is section 4.3 in the textbook. If you have a textbook and you want to, you can open it to page 152. That's where the work we're going to be doing is going to be starting. Also, at any time that you're watching this, feel free to pause so that you can do some practice and then restart it after you're done. So, one of the things that I will be asking of you is just to listen. I will be giving you examples, and so you'll need a pen and a piece of paper available. So at some point, if that's not what's going on, please go ahead and get a pen and a pencil, paper and a pencil, so that you can do some practice, and then come back and restart the video. Anyway, today we're going to be talking about multiplying monomials, and before we get into that too far, I want to make sure that we talk a little bit about this idea of terms in factors, and remind ourselves what is it that can be canceled. So there is a rule with fractions that we can cancel like factors, and again, a factor is a number that can be that's being multiplied. So how do we do that? That means if we have a fraction like 25 thirds and we're multiplying it by something like 12 tenths, I guess that could be easily simplified anyway, but what we can do is we can see common factors in the numbers like 25 and 10 and the 3 and the 12, and be able to reduce the fraction before we multiply. For instance, we see inside the 10 that there's definitely a 5. Inside the 25, there's a 5 also. So we can divide out the 5 from the denominator and the numerator and reduce the fraction. There are 2 5s in the 10, and there are 5 5s in the 25. So we can cancel that factor of 5 on both the top and the bottom. Similarly, the 3 and the 12 also possess a similar factor. The 3 contains a factor of 3, and the 12 also has a factor of 3, and we can cancel those factors out. If I cancel the 3 out of the 12, I'm left with a 4. If I cancel the 3 out of the 3, I'm left with a 1. We're not fully done because the 2 and the 4 can also have a factor of 2. The factor of 2 divides into itself 1 time. The factor of 4 divides into itself 2 times. So the final answer is that we have 2 1s in the denominator, and we have a 5 and a 2 in the numerator. We multiply the numerators across, we get 10. Multiply the denominators across, we get 1, which is simply just 10. So I'm just saying this because there's some problems later on where we can cancel like factors when we're multiplying the fractions. But let's get to the matter at hand. In the what we're going to be covering today looks like this. Say, here's an example. You guys have seen this before, but I just want you to rethink how this works. If I'm multiplying x to the third times x to the fifth, again, as we talked about yesterday, is that we have an exponent refers to the number of factors. And guys, remember, factors are a number being multiplied. So we have 3x's being multiplied and 5x's being multiplied, and we're going to multiply them together. Well, what does that mean? Here's my 3x's being multiplied. Here's my 5x's being multiplied. And they're being multiplied together. So what does that mean? It means that now we have a total of 8 x's, which is 8 factors of x, or x to the 8. So how is that 8 related to the 3 and the 5? Well, simply put, that's saying that's the same as x to the 3 plus 5. So when we multiply bases, we are simply going to add the exponents. And again, you've seen this before, but I'm really asking you to try to remember and understand what's going on. So here's some more examples. We have, let's take something like b to the 7th and multiply it times b to the 4th. Take a moment, think about it. What are we going to get? We're going to get b to the 7 plus 4, or b to the 11th. Let me take another one. You can do this one on your own. We'll go something like x to the 5th times x to the 9th. Okay, on your paper, go ahead and write what you think that answer to that is. I'll give you 5 seconds. And I'll hope you wrote x to the 14th. Okay, good. Well, let's go ahead and move to some more exciting examples. So more to the kind of work that you're going to be doing tonight is you're going to be dealing with the full monomial. And what that means is something like this. I have 3n squared, and I'm going to multiply that by 4n to the 4th. A word that we talked about the other day is this one called the coefficient. The coefficient is the number that comes before the base. In this case, the base is n. And you absolutely are totally required to make sure that you know what the difference is between a coefficient and a base. It seems that no one forgets what an exponent is. And one of the things I talked about is that all numbers can be expressed as coefficient, base, and exponent, and I'll show you a little bit more about that later on, but the key is recognizing which is which. So in this particular case, the 3 and the 4, the coefficient, when we multiply these two monomials, numbers, we will multiply the coefficients first, and in this case, that gives us 12. And then what we'll do is add the number of factors of the base. Well, we have 2 factors of n in the first term and 4 factors of n in the second term. So total, we have 6 factors of n. So our final answer is 12n to the 6th. Now, tonight you're going to be doing some homework that's on page 152. And so I'm going to take some of the questions right from there and see if we can't feel good about solving them. So here is, I'll do some of the even questions. You'll be doing some of the odd ones. And again, if you can, please check your answers as you go to make sure that you know exactly what's going on and that you're not making any mistakes. So on page 153, let me start with an example, number 4. And number 4 is n squared times n squared times n. It's very important that you recognize that this is a multiplication problem. All right, that these are all factors. So we have 2 factors of n, another 2 factors of n, and a single factor of n, all being multiplied. So in total, we should have how many factors of n? Answer in your brain. You got n to the 5th, I would hope. So this was number 4. Okay, let's go to the next question. The next question I'll do is, let's get a little bit more exciting here. Let's go to number 10. So number 10 says, gives us 5x squared y, and we're going to multiply that by 3x to the third, 4 to the y. Now, again, everything is multiplication. There's no addition of these two. There's not addition. And we'll go to the coefficients first and multiply them. And we should get 3 times 5. What is that? And now what we're going to do is collect factors of x and y. So we have 2 factors of x in the first term and 3 factors of x in the second term for a total of 5 x's, 5 factors. And we have, though we don't have to write it, oftentimes if it's helpful, you can think of y as being y to the 1. So you have 1 factor of y and 4 factors of y for a total of 5 factors of y. Final answer, 15x to the 5th, y to the 5th. So let's get a little bit deeper into this. And we have, let's go to number 20. In number 20, it gives us a negative r squared s times a negative 3r s to the third times a negative s squared. Now, in this case, you may wonder what all the coefficients are. And when you don't see a coefficient, when you just see a negative sign, you might, that is the exact same thing as -1. And so we have a coefficient of -1, we have a coefficient of -3, and actually another coefficient of -1 over here. So when we multiply these 3 together, oops, that doesn't look very much like a -1 the way I have it written. Let me fix that. So -1, oh, doesn't look much better. Sorry about that, just remember. So we've got a -1 times Okay, guys, I hope that gives you an understanding of what you need to do or what skills you need to have before to do this assignment. I'm going to ask you to do, this is homework 4.3, and I am going to ask you to do questions on page 153, 1 through 29. Ooh, sorry about that. 1 through 29, odd. I would imagine that many of you will have the ability to finish this early. If you do, please avail yourself to work on other classes. If the substitute is happy that everyone has completed the work, I have said that they may be able to allow you to leave 30 minutes early, as much as 30 minutes early if everybody's done. Otherwise, they may not be able to do that. If so, just be able to occupy yourself and see if you can't be productive anyway. If you guys have any questions, go ahead and email me. Otherwise, I'll hope that this made sense and you understand what you're doing. To some extent, it's review work, but I really hope that you have an opportunity to kind of think about exactly why it is that we add the exponents. We're adding factors. So even though we're adding exponents, it really is multiplication. So I'll see you on Monday, and hope you have a good day. You take care, everyone. Signing off.